Every year, more than 1.2 billion fashion items are made from wool, a material that seems simple yet has held its place in the industry for centuries. But what makes this fiber so enduring? Behind every sweater, scarf, or heavy coat lies a process as intricate as it is precise. Beneath its soft surface exists a chain of transformation. The wool is sheared, washed, carded, spun, and finally woven into fabric. Each step refines the raw gift of nature through human craftsmanship and modern technology. From windswept pastures to factories that operate day and night, one truth remains unchanged. Wool turns what seems ordinary into a material that sustains an entire global fashion industry. After centuries of existence, wool remains a cornerstone of the global textile industry. Every year, over 4.4 billion pounds of wool are harvested from vast pastures across Australia, China, and New Zealand, three nations that together supply more than 60% of the world's total output. From sprawling farms covering thousands of acres, this raw material enters production lines to become everything from sweaters and scarves to upholstery fabrics and high-performance insulation materials. The economic value of the wool industry exceeds $80 billion annually, including both raw fiber exports and finished textile products. China stands as the largest processor and consumer, while Australia leads in the production of fine, high-quality wool. Yet beyond trade, wool represents one of the world's most renewable natural fibers, an enduring link between nature and technology, and a pillar of sustainable fashion that continues story thousands of years in the making. The journey of wool begins in the vast open pastures of New Zealand and Australia, where farmers manage flocks under strict standards to ensure the cleanest and most consistent fleeces. Each farm carefully selects breeds according to production goals: Merino for ultra-fine fibers, Romney or Corriedale for longer, stronger, and easier to weave strands. Every sheep is tagged and recorded with details about its age, health, and fleece yield. The flocks graze rotationally to keep the soil fertile and prevent overgrazing. Their diet is supplemented with hay, grains, and minerals to promote thick, uniform, and bright wool growth. Barns remain dry and well ventilated to prevent parasites and skin disease. Each season, farmers vaccinate, deworm, and inspect every animal because the sheep's health directly determines the fiber's quality. Before breeding season, ewes undergo a process known as flushing, where their diet is enriched for several weeks to boost fertility and produce stronger lambs with finer wool. During lambing, mothers are kept under close supervision to ensure that newborns nurse promptly. After a few weeks, the young are tagged, weighed, and moved to lush pastures for weaning. When the warmer months arrive, the flocks are washed, treated for ticks, and left to dry naturally before shearing. Each sheep is handled gently to avoid stress, ensuring a single clean, unbroken fleece. After shearing, they are checked again, treated for minor cuts, and allowed to rest before returning to the fields. Every stage, from nutrition and care to shearing, follows strict animal welfare standards because only healthy sheep can produce wool that is pure, durable, and of the highest value. After months of care, when the sheep's fleece has fully grown and the weather begins to warm, the shearing season begins. This timing ensures the sheep stay comfortable after shearing and have enough time for their wool to regrow before winter. Before the process, the flock is kept in clean, dry pens and fed lighter portions to keep them calm and steady during handling. The shearers, skilled professionals trained to handle each animal safely, use precision electric clippers with fine blades, moving in a specific sequence starting from the belly and legs, then continuing to the sides, shoulders, and back. The goal is to remove the entire fleece in one smooth, continuous motion without breaking or damaging the fibers. An experienced shearer can shear between 200 and 250 sheep per day, averaging just 1 to 2 minutes per animal. Short, dirty wool from the belly and legs is separated for lower-grade products, while the long, fine white fleece from the back and sides is reserved for high-end textile manufacturing. After shearing, the sheep are checked for cuts or abrasions, treated with antiseptic, and allowed to rest in wind-sheltered enclosures. Each large fleece, the result of a full year of care and growth, now becomes the very first raw material in the industrial journey of wool. From the shearing sheds, freshly shorn fleeces are sent directly to the sorting area, where human craftsmanship remains essential amid modern automation. Each fleece is laid flat on wide tables and examined for color, fiber length, and fineness. Any sections tangled with grass, dirt, or too short for spinning are removed. Skilled graders separate the fleece by region. Wool from the belly and legs is reserved for industrial use, while the long, clean fibers from the back and sides are set aside for fine textiles. This meticulous stage not only maximizes the value of every fleece, but also ensures consistency across production lots before the wool is compressed into bales and sent to the scouring plant for cleaning. Once the sorting process is complete, the clean fleeces are gathered and moved to the baling area. Here, powerful hydraulic presses compress each batch into dense rectangular bales weighing between 300 and 400 pounds. Tightly wrapped in burlap or heavy plastic to protect them from moisture, each bale is tagged with detailed information, including the farm of origin, sheep breed, and wool grade, ensuring full traceability throughout the supply chain. The massive white bales are then carefully loaded onto specialized trucks and transported to scouring plants, where the wool's industrial journey begins through washing, degreasing, and purification before it becomes the foundation for fine textiles. At the raw material processing area, the wool bales are unpacked and spread evenly onto conveyor belts for cleaning. The first stage takes place inside an opener, a machine equipped with multiple rows of high-speed rotating metal teeth designed to separate tangled fibers and remove embedded impurities like dust, grass, and soil. This loosens the wool and prepares it for better water absorption in the washing stage that follows. The scouring system consists of 6 continuous hot water tanks operating between 170 and 180 degrees Fahrenheit. The first 3 contain a diluted soap solution to dissolve lanolin, the natural oil secreted by sheep that protects their fleece from moisture, while the remaining 3 are filled with clean water for thorough rinsing. Water is filtered and recirculated in reverse flow through automated pumps, saving energy and maintaining consistent quality across batches. Between each tank, soft press rollers gently squeeze out dirty water without damaging the fibers. Temperature and flow sensors automatically adjust the wash parameters to keep the system at optimal safety levels. The extracted lanolin is collected and refined separately for use in cosmetics and pharmaceuticals. Finally, the clean wool enters a rotary drum dryer, where warm air circulates evenly while the drums rotate continuously, allowing the heat to penetrate every strand. When the process is complete, the fibers reach a standard moisture level of about 12%, soft, bright, and completely free of impurities, ready for storage and quality inspection. Inside the material conditioning facility, dried wool bales are fed into a fiber blending machine. Each batch, differing in color, fineness, or origin, is precisely weighed and mixed by rotating rollers with spiral blades that separate fibers clumped during drying. A mist system keeps the air humid and static-free, while sensors control the speed for perfect uniformity. The fibers emerge soft, light, and elastic, ready for the next mechanical stage. Entering the structural formation phase, the dried wool is fed into the carding section, where loose fibers are realigned into a single uniform direction. The material passes through the carding machine equipped with multiple metal tooth rollers spinning at different speeds to create controlled friction and pulling force. Through this continuous motion, tangled fibers are separated, straightened, and gradually refined. Throughout the process, dust extraction systems and electronic sensors remove short fibers, fine dust, and impurities left from previous cleaning stages. As the material exits the chamber, it emerges as a thin, continuous web of fibers that is automatically rolled into soft slivers of consistent thickness and weight. Carding restores the wool's natural structure and enhances the cohesion between fibers, a critical factor determining the smoothness and durability of the final textile. In many small-scale workshops or traditional handcraft studios, artisans still preserve the ancient art of hand carding using metal combs. Two brush-like paddles covered in fine steel teeth are interlocked and pulled apart repeatedly, a motion performed dozens of times until every fiber lies perfectly parallel. Though time-consuming, this manual technique allows for delicate control of tension and pressure, preserving the wool's natural elasticity, sheen, and texture in ways that machines can hardly replicate. Once the combing stage is completed, the long and refined wool slivers are transferred to the spinning section, the critical phase that determines the strength and fineness of the material. Here, the fibers enter a multi-roller spinning frame, where each roller rotates at a slightly different speed to apply a gradual drafting tension. The front rollers hold the fiber steady, while the rear rollers accelerate slightly, drawing the sliver thinner while maintaining its elasticity and internal cohesion. Before the twisting unit, the surface of each strand is coated with an ultra-thin layer of spinning oil, reducing friction and preventing static buildup caused by continuous movement. As the fibers pass through the central twisting assembly, they are tightly bound together into a unified strand, forming a structure that is both strong and resilient. The degree of twist is monitored by tension sensors, ensuring perfect consistency along the entire length of the yarn. Next, the finished yarns are wound onto large bobbins and later rewound into smaller spools of standardized size. Optical scanners inspect each strand in real time, detecting thick spots, weak points, or over-twisted sections. Any flaws are automatically trimmed and rejoined using heat fusion, producing smooth, seamless joints nearly invisible to the naked eye. In smaller workshops, traditional artisans still preserve the heritage of hand spinning with a spinning wheel, relying on tactile control to adjust the twist intuitively. This slow and deliberate method yields yarns with a distinct organic character, often reserved for high-end handcrafted woolen products. The final yarn emerges with exceptional tensile strength, smooth texture, elasticity, and structural integrity, the result of precise engineering combined with generations of craftsmanship. In the next stage of production, the wool yarns, now refined to the ideal balance of fineness and strength, enter the weaving system, where the material transforms from loose threads into a unified textile structure. Before the process begins, automated sensors measure the tension, humidity, and density of the yarns to ensure stable operation throughout the weaving cycle. The first task is warping the yarns onto the loom. Thousands of strands are threaded through needles and heddles, forming the structural foundation of the fabric. Each strand must align precisely, as even the slightest deviation can disrupt the intended pattern. Once the warp is perfectly aligned, the real transformation begins. Weft threads shoot through the loom at incredible speed, either carried by a flying shuttle or blasted across by powerful air jets. With every pass, the reed slams the threads tightly into place, locking them firmly with the warp. The loom moves fast, but nothing goes unnoticed. Advanced fault detection sensors monitor every motion in real time. The moment a yarn snaps, tension slips, or the pattern drifts off sequence, the entire machine stops instantly, giving operators a chance to intervene before a flaw spreads. When the fabric reaches its exact programmed length, it is smoothly wound onto a take-up beam and sent under intense inspection lights. Here, trained eyes catch what machines might miss: tiny knots, dark specks, or slight tension inconsistencies, all carefully corrected by hand. At this stage, the wool fabric has taken on a strong internal structure and a clean, even surface, forming the backbone for everything that comes next. The fabric then moves into the finishing department, where raw structure turns into refined performance. The process begins with fulling, submerging the fabric in warm water while gently agitated. As the fibers swell and interlock naturally, the cloth becomes thicker, denser, and dramatically warmer, enhancing its thermal insulation and durability. Next, the fabric glides through fine carding rollers lined with delicate metal pins. These smooth the surface, lift loose fibers, and create a soft, uniform finish. Selected batches are dyed to precise design specifications, then steamed to permanently lock in both color and dimensions. The final step is slow, controlled drying at low temperatures, preserving the wool's softness, elasticity, and natural sheen. What began as a rough textile now emerges as a smooth, resilient material, ready to become tailored coats, premium suits, or luxurious blankets. In the final phase, the finished fabric enters the cutting and sewing floor, where cloth becomes clothing. Inside climate-controlled rooms, temperature and humidity are carefully regulated to keep the material stable. Automated rotary blades glide along digital templates, slicing fabric with absolute precision. Each cut piece is numbered and routed to sewing stations, where double needle machines assemble collars, hems, and sleeves under steady steam presses that lock in shape and structure. After a final inspection, every garment is steamed, folded, sealed, and labeled, prepared for shipment across the world. The journey is complete. From wind-swept pastures to the precision of modern textile mills, wool's journey is a powerful example of harmony between nature and technology. If you found this transformation fascinating, like the video, share in the comments which stage amazed you most, and subscribe to Factory Vision to explore more incredible stories of how ordinary materials are shaped by human ingenuity and industrial mastery.